Okay, everybody. So I'm Justin Carter. I'm the Conveying Product Manager here at Conair. What I'm going to talk to you about today are two of our recent developments with our engineering team where we're using AI to solve problems that operators and processors see every day. So the first one of those being our Conveying with Optimizer system. So I'm standing in front of this demo here, and what this product does for us is it takes a lot of the manual control, manual adjustment out of our conveying systems. So, when you're working with either varying distances, varying materials, different bulk densities, really all of those require unique adjustments. Typically that comes in the form of a manual distribution box underneath your conveying source. You're opening that to allow more material in, closing it to kind of cut off the material and get more air in the system. What this product does is it automates that whole process. And in that, we're constantly monitoring the system. We're gonna see maybe things that change in real time, and we're gonna react with it. So right now, this is a system that's running in a good state right now. We're conveying material up to the receiver. We feel pretty good about how we're operating. What we're gonna do here in a second is we're gonna induce a vacuum leak in this system. So we're gonna see what happens when there is a vacuum leak. Logically, what we expect to happen is that we're gonna get more air in the line and our level of material is gonna drop. So I'm gonna have Chris here throw a vacuum leak. On our control here, we're constantly measuring our vacuum level in the system. So we're now gonna be detecting the fact that we have a source of air that is kind of uncontrolled right now. That's gonna mean less material in the lines, ultimately less material getting to my receiver. In a production environment, this may mean that your machine receiver is now gonna be falling behind. You're gonna be struggling to keep up because you're not getting the material there that you think you should be getting. So we're trying to run right around 8.5 inches of mercury on our vacuum pump. Once we induce this leak, we're only running about 6 inches right now. So we're detecting that change from 8.5 down to 6. And now our valve is gonna start modulating. It's gonna start changing to boost that vacuum pressure back up and ultimately get more material back in the line so that I can get material to our machine the way we need it to. So this is a great solution for maybe somebody who's working with a common line system where one receiver might be, 100 feet from your material source, or my next one might be 200 feet, and I have that big gap in distances all from one material source. It's a great thing for maybe processors who change materials on a repeated basis. So I might run a regrind one day that's 25 pounds per cubic foot, or I might be running a virgin resin that's 35 or 40 pounds per cubic foot. Those changes in bulk density also affect how much airflow I need to move that resin. So as I've been talking, our valve is adjusted and we're back up over 8 inches of mercury. So within about 2 to 3 load cycles, we've already caught back up to the vacuum pressure that we were at when we started. So now we can take that leak away, and all that air that we were inducing with the leak is gonna go away. It ended our vacuum cycle, so it's gonna pick up basically where it left off in the last cycle, and we're gonna notice a slug that's gonna move through the line because all that air that we were putting into the system is gone. Once this slug moves through the lines, going back the other way, normally this would be a situation that's gonna clog a line or create something that the maintenance team is gonna have to troubleshoot in the system. Instead of having that plug or that clog somewhere that now we've got to go hunt down, we've got to find where it's at and start taking stuff apart, we're going to now induce more airflow into the system and move this all through and get us back to that 8.5 inches of mercury that we wanted to. So this is our most recent advancement. on the conveying side, something that we're really excited about. We love what this is going to do and how it's going to make people's lives easier from both a commissioning and just an overall operation, because this will adapt to changes before you even really understand that something changed. Similarly, on our drying equipment that we have right over here, we have, I guess, a development that kind of initiated from this product with our ResinWorks system. So traditionally, our ResinWorks systems are one dryer hooked up to multiple drying hoppers. That dryer is supplying our airflow, and then each hopper has its own individual heater that is controlling the drying temperature for that hopper. Generally, when these systems are set up, I have a dryer that is pushing 100% of its airflow to this manifold to all of these hoppers, and then all of these hoppers might be running different, I guess, throughputs of material. So let's say one day I'm running all of these hoppers at 100% of the throughput. So, that's full airflow on the dryer, full airflow through each of the hoppers. Everything is balanced. We're in a good condition. But maybe tomorrow, my production schedule is a little bit lighter. So now I only need, let's say 50% throughput on the first hopper and 40% throughput on the other two. Well, now that means I don't need 100% of my airflow from my dryer. I can scale that back and reduce my overall throughput, or reduce my overall, air requirement. So we've taken what we learned on the Conveying with Optimizer system, and we've now built that into our drying system to where I can monitor the temperature of the resin as it's making its way through the hopper, and I can adjust the airflow that I'm allowing into each hopper so that I'm not basically over drying the material. I'm not running more airflow than what I need through the drying hoppers at any given time. And ultimately, because I'm running less airflow through the drying hoppers, if I have a VFD on my dryer, now I can scale back how hard that blower on the dryer is working and lead to energy savings. So with different tests that we've run in our lab, we've seen anywhere from 20 up to 40% energy savings with our ResinWorks with Optimizer because of that, I guess, change in throughput. So change in airflow. Really, all that we're asking a user to do is go up to the controls that are on the drying hopper or the dryer, and all they're doing is they're telling us what the resin is and what the overall throughput is. They're not having to manually adjust things, where a lot of the ResinWorks systems, at least from Conair or other suppliers, you have a manual lever that's on there that you're adjusting the airflow manually. So if I have a proximity sensor or some sort of remote demand sensor, I might move that up or down on the hopper. That's going to change how much material is physically in the hopper at any given time. If I'm operating the system correctly, once I change that material level, I should also be changing how much airflow I'm giving the hopper. Realistically, I don't think most operators are making that change. They're just leaving it wide open. They're running full airflow through systems. It's leading to energy waste. It's leading maybe to over drying of material. So we've used our AI systems now to eliminate some of the changes that we're not adjusting for in conveying. We're also eliminating those same challenges in our drying systems now.